That's from the question. And then we want to use Z to generate this. And Z, rho Z, we know it's the standard uniform. So what is the density? The best one, right? And then here, and we also have U. So this doesn't matter. So we know this one is follow the uniform. Okay. And we are given these 6 numbers here. So I'll just reorder it. Just consider that's the number we have. So I, EI, okay, and this is UI. So let me reorder them. So I just want to copy the number so we can have that. We will see it a little bit later. 0.9138, 0.8375, and 0.0595. Okay, so you can see I pair this as this case. So at least we have 3. So we can have some possibility or possible to make sure we can have 2 instances because we want to generate 2 instances for that case, not say 6 instances. Okay, this is what we have. Then what is the first step? The first step is to find C, right? How can we find C? Because C should be some value less than or equal to 1, from 0 to 1, and such that this rho Y is less than or equal to 1. Okay, then let's see what is rho YZ divided by rho CZ here. So it's 2 over Y plus 1 squared divided by, C plus 1. And then this is 1. So it's 2 over C plus 1 squared. And C is from 0 to 1, right? Because they have the common space. So what is the maximum value of this case? Maximum value is 2 when C is 0. Okay, we want to find C such that times this ratio with all the Z less than or equal to 1. So what is the maximum value of C we can get? So this tells us we should have C is equal to 1/2. Okay, then we have the case. Then we know this one is exactly equal to 1 over C plus 1 squared. Okay, and this is Z from 0 to 1. Okay, when we have this, then we can move to the second step. So trying to decide, because here, if we go back, so we're trying to check, okay, what happened is for this case, we have the C times this, we use X, but in the example is Y. So trying to generate this one, so, and find the corresponding UK, and to know if we can satisfy this inequality, then we will assign this ZK to Y, right? So that's the case. Then we try to calculate, right? So we try to compare. So K is 1, maybe not use I, but it's the same. So K here. Okay, K is 1. So we get this C times rho Y C1 rho Z C1 is exactly equal to 1 over 0.3554 plus 1 square. Okay, what is the answer? Can you calculate that for me? Use your calculator, your cell phone. And we want to use this to compare with the 3408.
That should be 1 over.
No, don't tell me 1 over something. Tell me the exact number. 1 over, I don't know the value. Okay, thank you. We got some answer here. Okay, don't tell me 1 over, okay? Thank you. Thank you, Rajesh and Zia. Okay, we get the answer, okay. Online students work faster than you guys, okay? Okay, so what does that mean? When we get this is true, so which means W1 should be 1. So which means we accept this. So what is the Y value? Okay, Y1 should be Z1. And what is Z1? 0.3554. Okay, so this is the one we use to compare. And then this is the one, actually, the value you take is Z1. Okay, then let's see the second case. So K is true. Let's calculate this one on Z2. Okay, so right now I'm using the 0.9331. Okay, so for this one, I want to compare with this 0.9138. Okay, I don't need to do the calculation. I know this is definitely not possible. So it will always less than that. You can imagine this one is close to 1. So the whole thing actually should close to 0.25 or a little bit greater than 0.25 or less than 1/2, definitely. It can never be greater than this case. So, but if you have the answer, let me know, okay? So if it's less than that, so what does that mean? So, okay. Thank you. So we get this is 0.26, sorry. 76. So it's less than that. And this is U2. So which means we will do something here. So which means we will reject. So put reject here. We will reject C2. Then we will try to do the third one. K is 3. We still try to calculate that. Where's mine? Okay. So C times rho Y Z3 over rho Z Z3. It's 1 over, what we have here is 8375 plus 1. That's what we have, and we have this is U3. Okay. Rajesh, what's the answer? But 0.2962. Okay, good. So this one will be very closer to the second one. However, we have this one is quite small. So even though in this case, we will still accept this. So which means, okay, be careful is Y2. Okay, here is Y2 will equal to C3. and the value is 0.8375. Is that okay? So this is acceptance rejection method. I think this one may give a better like illustration how we try to reject that or accept this, and what you try to accept actually is the value here. So that's why you try to, that's how we do it. So you actually, the idea for the acceptance rejection method, you try to generate a z, and then based on this ratio and compare with this uniform random numbers, and then to choose if this one can be accepted or not. And if it's greater than that, then we will accept that. So this tells us actually if the ratio can close to the maximum value, when the value is close to 0 actually, so we will have higher chance to accept it. This is based on this density function here. So that's the case. But for this one, we have the last one, we have some extreme case because the u value is quite small. So for this time, we will still accept this, but still that can happen. Okay. So of course, if we just generate like 2 instances, then if we check their sample mean, of course, it can be far away from the true expectation. But you are asked to generate 1,000 sample, like the 1,000 sample instance. So the answer, like in the homework, when you try to calculate the expectation, the sample mean, of course, it won't be exactly equal to the true expectation, but it should close. Okay, don't expect, okay, your sample mean can exactly equal to the population mean. That's not possible, okay? But we have 1,000 samples, so 1,000 random numbers, so it should be okay, not too far. Like if it's 2, then I get it's 1. Then that doesn't make sense, okay? So that's why you need to calculate the expectation and variance by yourself, and just in case to verify you get the correct answer, okay? All right. So this is about the inverse transformation method and also the acceptance rejection method. Is that clear now? I think it will be nice, like you try to work on it, work on the assignment by yourself, because this is a good practice. So even though this one is a computer problem, so the first step is still to find C. You still need to know the value of C, because then you know how many like random numbers you need to generate, like at least the average. Okay, it doesn't mean you can always do that. Try to also do some inflation factor, because that's the expectation. So which means like 1,000 over C doesn't guarantee you can use this sample size to really can generate 1,000 sample instance from this distribution. Try to make a little bit larger to make sure you can generate 1,000 random numbers. Okay. And you still need to do some handwritten part. And of course, for this one, it's a practice for you to do the inverse transformation. So this one can be a little bit complicated because this one we have piecewise density function. So you need to do the calculation a little bit careful, because it won't be just one cumulative distribution function. For at different like subinterval, it will be a little different. And similar here, I think this part is just trying to help you understand how we can really start from standard normal to generate some other normal random numbers based on the covariance matrix. If we already know that, how should you try to do it? That's important, okay? All right. Okay, this is some practice like for you to do the computer problem from the 0, 1 to be this case, okay? All right, so this is the homework. Do you have any questions?